students, we are going to discuss the pseudo force today. We have already discussed about frame of references, that is inertial frame of reference and non-inertial reference frame. The previous video, if you look at all these things, you will get. So I will revise the things. So I will talk about first inertial frame of reference. What is inertial frame of reference? A frame of reference which is either at rest or in uniform motion with respect to any other inertial reference frame. Now, this is a definition of inertial reference frame. Here, Earth is considered to be an inertial reference frame. If Earth is an inertial reference frame, then with respect to Earth, any other frame is from where the observing the system is at rest, then I will say that is also an inertial frame. If that frame is moving with constant velocity or uniform velocity, then also it is an inertial reference frame. And on the contrary, non-inertial reference frame. Non-inertial reference frame. A frame of reference which is accelerated with respect to any other inertial reference frame. Such reference frame which is accelerated with respect to inertial reference frame is called a non-inertial reference frame. Example we can take: a car is moving with certain acceleration. So, person is standing on the earth. He is observing. So, anything observed from earth will be from inertial reference frame. Any system observed from observer in the car which is accelerated with respect to earth, he will be called a non-inertial reference frame. Right? See, two frames I have considered, one S, another S dash. S is the inertial frame of reference and S dash is non-inertial frame of reference. If it is a point mass, the mass is kept at the position P. So, with respect to O dash, what is the position vector of this P is R, and the origin of this frame, and this is the origin of this frame, inertial frame S. With respect to this, the position vector of O dash is R0 and position vector of P is R1. This is R1. So by triangle law of addition of vector, what do we get? R1, right, is equal to R0 vector plus R vector, right? Or we can write R vector is equal to R1 vector minus R0 vector. If we differentiate this position vector twice, then what will we get? Therefore, dr upon dt, that is equal to dr1 upon dt minus dr0 upon dt. This tells the velocities, right? This is the velocity of what? Velocity of p with respect to s dash, isn't it? Velocity of p with respect to the frame s dash. This is the r1 upon dt. R1 is this vector. So it is the velocity of p with respect to s minus dr0 by dt, and we are talking about this frame, that is velocity of s dash with respect to s. Clear? We will differentiate it once again. Therefore, v dvp s dash upon dt is equal to d vps upon dt minus d v s dash s upon dt. What is this? This is the acceleration of p with respect to s dash is equal to, this is the acceleration of p with respect to s minus this is the acceleration of s dash with respect to s. Remember this. S is the inertial frame and S dash is non-inertial frame of reference. And Newton's law hold good in inertial frame of reference. And whatever force is applied on the mass, and that will create acceleration by F by m. So suppose the mass of this is m, right? So we will denote now. If we denote acceleration of p with respect to s dash as a, is equal to a ps minus acceleration of s dash with respect to s is a naught. A naught is the acceleration of s dash with respect to what? With respect to this inertial frame, a naught. So what is what that I will mention? A, the acceleration of p with respect to s dash, aps that we know, a naught, the acceleration of s dash with respect to s, and this is the acceleration of p with respect to inertial frame. If we multiply the whole equation by mass m, then therefore ma is equal to m aps minus m, this is ma. What is maps? This is the acceleration of p with respect to inertial frame multiplied by mass. It means mass into acceleration. It is a total net force acting on the mass m, because it is the acceleration with respect to inertial frame, and we know Newton's second law hold good in inertial frame of reference. Means this is the total force acting on the mass m, right? So we can write therefore ma is equal to total force F minus it is m naught, that is m a naught. This is mass into acceleration. This is the force, right, which is observed by the observer in s dash frame, right? This is s dash. It means the force observed by the observer in non-inertial reference frame, that will not be equal to F. Some new quantity has come in this, right? So this is the, we can write ma, the force observed, experienced, right? Force on the mass m observed from s dash. A is equal to F minus ma naught upon m. This acceleration observed in non-inertial reference frame is not f by m, because if from inertial reference frame, if you look at, total force is f, mass is m, acceleration suppose a ps. So a ps is equal to total force acting on the object divided by m. Therefore, this can be written as f plus minus ma naught upon m. It is the acceleration observed by the observer in non-inertial reference frame. And this quantity ma naught, which is added in the net force acting on the object when it is observed from inertial frame of reference, this much force will be added, that is this minus ma naught. This will be added in what? The net force acting on the object when it is observed from inertial frame of reference. And this is the force, this is called pseudo force. This much amount minus ma naught will have to be added in the total force, and this is called pseudo force. With certain example, things will be more clear to how does it work. To understand pseudo force, I have taken 3 different cases. First, this is the trolley. A mass is hanging from the string. It is rigid support and m is hanging from here, and the observer is standing over here. This is at rest. It is not in motion. So, when he will observe, he will say that the whole system is at rest. This mass is also at rest. So, mg is acting downward, tension T is acting upward, and the net force is T minus mg, that is equal to 0. Therefore, T is equal to mg. It is the first case. This is the second case, and this is the third case. Right? So this is the observer. Observer. This is ground. Ground means earth. Means inertial frame. Trolley is there. It is on the earth. Again, second observer. It is on the ground. Means the person is in inertial frame of reference. Second case. Now, it's when this accelerating, the trolley is accelerating with acceleration a. It is moving in this direction with acceleration a. So, observer will say there is acceleration in the mass. But if we see mg is acting downward, tension is acting upward, the bob is at rest. From where this force will come to accelerate this? It means the situation will change. This bob will come over here. Tension T will get created. Mg will be acting downward, and it will be making some angle theta, and component of these fitted in this direction, it is T. This will also be theta. This is T sin theta. In this direction, it is T cos theta. So T cos theta will balance this way, but this is unbalanced force, and this will create acceleration in this bob. See, observer is here. Observer will say that this trolley is not at rest, and since it is hanging, it is not the rigid support, it is string, right? If it would have been the rigid support, along with the trolley, the whole system would have moved. But since it is the string, right? So some force is required to take it, because you see upper part is attached with this. So upper part will move, but by inertia it will remain as its place. Its position will be something like this. This will be moving with acceleration, and this will come over here. And this tension, resolved part of this tension will create the acceleration in the bob, because he will say that bob is moving with acceleration A. So from where the force will come? The force will be produced by this tension. So here in this case, this is the inertial frame of observer is in the inertial frame of reference. Therefore, T cos theta is equal to mg, and t sine theta will create, this is the net force acting, and this is creating the acceleration A in the mass m. The mass is m, that is m into A. This is when it is being observed from inertial frame of reference. The observer is in ground. This is the second case. Third case, it is moving with the acceleration A. Now observer is in trolley. Means this is the frame of reference. Means accelerated frame of reference. Means this observer is in, this is the observer. Observer is in non-inertial reference frame. This is non-inertial reference frame. Now the observer is in non-inertial reference frame. It is, the observer is also moving with the acceleration A, right? So he will say that the bob is at rest, isn't it? Since it is in the non-inertial reference frame, actually situation is such that it is getting accelerated, right? The trolley is getting accelerated, the similar situation should prevail, and he will say that it is accelerated, he will say it is at rest. So net force, acceleration is there, definitely, acceleration is there in this, but since the observer is in non-inertial reference frame, a pseudo force will act in opposite direction. So when pseudo force acts, because when it is moving, situation will be like this. Situation is like this. So he will say that it is at rest. When it is at rest, means all the forces should balance. This is tension T, mg is acting downward. So to balance the forces, pseudo force will act in opposite direction, that is ma. Acceleration in this direction. So ma will act in the opposite direction as we have seen, right? Inertial frame, what is the net force acting? That is T, tension, and mg. So opposite force, that is minus ma, will act on this when the observer is in non-inertial reference frame. So this is the system. Now the forces will be balanced and the observer will say it is at rest, right? Here if you look at, this is theta, this will be t cos theta in this direction, this is t sin theta. Now forces are getting balanced. Here also t cos theta is equal to mg, upward force, downward balance, and t sin theta is equal to m into a. In both the cases, when it is observed from inertial frame, we are getting this relation. When it is observed from non-inertial frame, we are getting the same relation. Because Newton's laws of motion, it is universally true, whether in inertial or non-inertial. The situation should be same. So for the sake of that, a pseudo force will have to be applied so that the result will be same in both the cases. Whenever it is observed from inertial frame, this is the relation I am getting. When it is observed from non-inertial frame, the actual situation will not change. That is why this pseudo force will be applied on this mass, so the relation will be same in both the cases, right? So with this example, concept of pseudo force is clear. When it is observed from inertial and non-inertial, I think understanding of pseudo force is there. If you solve number of problems, concept will be more clear to you. So I will meet you again with some numerical problems based on this. Till then, all the best.